Right now, it is my pleasure to introduce you to two guests who are bringing the future of dairy farming right into the present. It may seem like sci-fi stuff, being able to shift to manage to monitor your herd remotely. But Dan O'Brien from Amazon Web Services and Mark McLeod-Smith from Halter are joining me in the studio to discuss farms without fences. Welcome, gentlemen. For those of us sitting at home who don't know what Halter is, what's Halter?
Sure. So I guess we're an ag tech company started in New Zealand, and I guess what we do is try to help farmers move and manage their dairy cows. And so I guess how we do that is we have a collar that goes on every single cow in the herd, and that gets coupled with a mobile app that the farmer can use. And really what we do is give cows directional cues to help them understand where they can and can't go. So for a farmer, that allows you to set up virtual fences or temporary fences that are virtual in nature. So you don't need to use reels or standards anymore. It allows you to shift cows remotely, so you don't have to walk behind cows anymore, and you can shift them from your kitchen table. And also we collect a lot of data about the cow's health and well-being, and so when a cow's on heat or calving, we have a really good understanding of that. And so I guess ultimately, we kind of pair that collar with some digital smarts to help farmers, make life a little bit easier for themselves.
Right, there's going to be a lot of children out there on foggy winter mornings with a lot more time on their hands, not having to pull electric fences out. How does it work?
Yeah, so I guess on a farm right now you have physical fences, you have farmers, dogs, and so you have a range of, kind of physical or visual cues as well as audible cues. And so we have this, there's a body of science called Pavlovian conditioning, which we use to essentially retrain cows to respond with the same behaviour, but to a slightly different set of cues. And so with a collar, we put the collar on the cow, and it uses a range of kind of audible and vibrational cues to essentially elicit the same behaviour. So, rather than having to walk behind cows or kind of yell at them and get them to move where we want to, we can really deliver that over the collar.
Nice. Like being able to farm via PlayStation. We've actually got a video. Shall we have a look at it?
Yeah, let's do it.
Well, it all seems very simple, but there's an enormous amount of tech going on in there. How did this all get started?
Yeah, so I guess it got started with a guy called Craig Piggott, who's the founder. And so he grew up in the Waikato, and after kind of growing up on a dairy farm, moved to Auckland and ended up working at Rocket Lab, actually. And obviously Peter Beck and the team there are building some pretty world-leading technology, and so spending kind of Monday to Friday at Rocket Lab and then going back and seeing mum and dad on the farm in the weekends. And I think he kind of said to me, noticed that there was the way that things were happening on the farm hadn't really changed massively over kind of a long period of time. And so I think that was really, where the seed got laid for him to, start thinking about it. And I think then it kind of came to the animal and going, well, if you're going to try and change something in farming, start with kind of the core, and I guess the core is the animal, being the cow. And what happens with the animal, obviously, is cows get moved around, and it's obviously important for them to have grass. And so we looked at ways for how we could make that way simpler for a farmer.
Marvellous. So what's the tie-in, Dan, with Amazon Web Services?
Well, it's a good question. nowadays, a farm will be capturing millions and millions of data points if they're all hooked up like this. So what are you to do? Are you to store all that data on your server in the shed? Well, no. I mean, the way to do it these days is to actually store it in the cloud. And AWS, Amazon Web Services, is all about the cloud. Cloud computing meaning you access those resources as you need over the internet using pay-as-you-go pricing. So this way, you only pay and use the resources when you need them, and you can analyze and see patterns in the data that you're storing in the cloud, and see if you can infer or make predictions based upon that. So I understand that Hulta are storing that data in the cloud that way. Yeah.
I love data. I love the unexpected outcomes of data. And the data that you're collecting, it's not just data that can be looked at reactively. There's some proactive data. You can tell a cow is ill before the cow literally knows she's ill.
Yeah, totally. So I guess we collect a ton of data. I think for the average farm each day, we're almost collecting north of 10 million data points. And I guess the way to think about that is it's really similar to your mobile phone. Have location data and movement data, and then we use that, as kind of Dan said, to infer kind of animals' behaviour. And so, I guess there's some really interesting things that come out of that. And I think one thing we kind of learned along the way is that cows are very stoic, and so often their kind of evolution's taught them to hide any injuries or illnesses they have. And so, whilst that for a human you can't see that, the data doesn't lie. And so when you look at a cow's behaviour over a length of time, things like that become far more visible, and it gives you a greater perspective as a farmer to really understand the whole health of the entire herd of cows that you have.
Dan, I don't know how much you knew about cows prior to all of
No,
this.
I learned a lot about...
What was the most surprising thing for you?
I learned about cow friendship and friendship between cows, and also the point made there about stoic cows. And it's interesting, just as you talk about that, Mark, that all this data being captured, how do you see the patterns in that data? That's the sort of thing that springs to my mind. And that's the beauty of the new techniques that we have available, and what is termed machine learning, and people have probably seen that termed around, that the machines can actually now start to help you and your team identify patterns in this, and all the data that you bring through. But the friendly cows was a great thing I learned about today, actually. Yeah.
Mark, what's the story with the friendly cow? Because we all know that a herd of cows has a very matriarchal structure. There are relationships between cows, bully cows and non-bully cows. What's the friendly cow scenario?
Yeah. This is something I guess we've uncovered, and it's still very early days. But I mean, through capturing various location data, you're able to see where cows spend their time, and thus which other cows they spend a lot of time with. And so, it's easy to see that cow 133 is kind of hanging out a lot with cow 155. And I think there's a lot of literature out there that talks about how, when they have friends and they spend time with them, they're a little less stressed. So
a lot like people.
A lot like people.
Yeah. Hey, look, cows are a robust kind of animal. They're in a very rugged environment. How do you build something that can stay on a cow and send all of this data through? What kind of testing do you have to do?
Yeah, it's tricky. So building digital necklaces for 500 kilo animals is not an easy feat. And so, you do need a lot of testing and rigor that goes into that. In the early days, we were, fairly fast and loose. And so we actually had an old Fisher and Paykel washing machine. We would chuck the collars in and put it on a heavy wash and kind of really check the waterproofness and the rigidity of them.
That strikes me as just a ridiculously New Zealand kind of thing to do.
Well, we had it hanging around and we thought we'd put it to good use. But thankfully, our testing is a lot more robust now, and so we do a lot of impact testing where we drop the collars from a height onto steel kind of boards, check all the impact. We do a lot of UV testing, a lot of waterproof testing. There's even one where we have a sledgehammer that swings into the collar, so we put them through the ringer.
You send them along to a kindy and get a whole lot of kids with hammers and get them to whack them. Once the data is there, one of the crucial things with data is that the more data you have, the more you know.
Yeah.
How advanced is it in terms of testing and uptake in the field?
Yeah, so I can talk broadly about what we're seeing with customers. When they're capturing all this data, that's one thing to capture the data, but actually to gain insight from it is a second thing. And typically the people that can gain insight have been studying data science degrees and a very specialized subject. So it's quite a hard profession to get into, but a very worthwhile one. So what we've done is we've actually, it's easier now with Amazon SageMaker to actually do that automatically for you, some of the processes of what's called data science, right? So capturing that data and actually finding the insights in the data. And so Amazon SageMaker believes being used at Halter to actually find some of the patterns that are there to make predictions on. And then once the prediction has been, the patterns have been found, you can actually deploy them on devices like a Halter to say, okay, we'll make this prediction automatically, or it could be a mobile phone or wherever it may be. So you can train your machine to actually find these patterns and then make predictions, what we call inferences, like our brain making inferences the whole time about things. You can train the devices to actually make those predictions.
We're being inundated with data in many ways. Do you think that people now have an aversion to data and think, oh, I don't need any more data? You know, is it the job of the likes of Amazon Web Service and stuff to help filter that data down so that what eventually reaches the user back is just what they want to know? That's
right. I often think that we're in a sort of like, as people, we're in a denial of service. There's too much data coming at us, right? And so our brains can't compute with all that information. So that's right. I mean, within those millions of data points, there are only some that are actually pertinent to you or I in our day-to-day lives. So as you train the models to see what is pertinent, so the data's labeled by trainers, and then the machine can, with that training data set, actually infer what is pertinent to you as an individual. Through those millions of data points, it will pick out the ones that are useful to you. So we see that in things like recommendation engines. We've all been on the website where you go on a site and then a recommendation is made. Okay, people like you bought this, or people like you travel to this sort of place. The amazing thing today is that this capability is available to every business in New Zealand, every startup, and around the world. So that's what we're really excited about, the fact that now every organization in New Zealand can take advantage of this. Yeah.
It's phenomenal. And look, I've seen what can be done with the likes of these collars. I know the Dutch are very advanced with a lot of what they've got, and that ability for animal health, animal well-being, animal management. For the future, what do you see in 5 or 10 years' time? What's the future of a connected farm, of a dairy farm, for example?
Yeah, I think what Dan said is really interesting, where there is almost an overload of data in some respects. And so I kind of always think if I'm a farmer, there is plenty of data and there's plenty of devices that I can use to manage my farm. Some of the good ones present that information really well. And I think then it kind of comes back to me making decisions around how I manage my farm. But I think that the last step there to kind of really, I think, bring that connected farm to life is really about automation and using all this data effectively, but doing it in a way which actually reduces the workload of the farmer. So, be that actually moving cows or having a robotic milker that actually reduces their workload. Because, we all know just how tough it is to spend, so many hours of the day out on the farm, and your to-do list never gets shorter. And so I think it's really about taking the data that we have and really trying to find ways to use that where it's not adding more to the plate of a farmer who's already pretty full up.
And in fact, yes, you're right, and just that ability to just monitor things remotely. One of the nicest sort of examples I saw was, I think it was a bull farmer using technology like this. He said the animals that are struggling, doing a little bit worse, you can just sit at home and give them another 10 or 15 metres of grazing remotely without having to go down.
Well, it's quite funny. So we did a demo for some investors, and investors in Silicon Valley don't know a whole lot about how a dairy farm works, and so we thought rather than try and explain it, it's probably better to show them. So we floodlit our dairy farm. We have a test farm in Morrinsville, and from 10,000 kilometres away, we let these investors shift our cows in Morrinsville. So as far as I know, I think that's a record, but happy to be proven wrong.
Tell you what, there's going to be a few dairy farmers looking at their schedule and thinking, I can probably do this from the beach house. Fascinating. Hey, thank you very much, gentlemen. This is the future of farming, and it's happening right now. So, thanks to Dan and Mark, and it really does feel like, in some ways, we've crossed that sort of space-time continuum when it ended up in the future with happy cows and farmers.